Alright, what's up everybody? I'm going to make a quick demonstration video of the pressure transducers and power supply boxes that I use with my Handtech oscilloscope. I know a lot of people are interested in them. I know there's a lot of people interested in purchasing them. Will they be made available for sale? Most likely. Again, we'll get to that later on down the road. If you have any questions, just leave them in the comments, or the other forums that you can find me on. Anyway, I'm going to try and make a quick video here. Like I said, I'm just going to kind of run through this, just basically what they are, what they consist of, how to use them, and then a small demonstration. Not really going to get too involved with it other than that at this particular moment in time. Anyway, what we have here are 3 pressure transducers. This one is a 100 psi transducer. I mainly use this for fuel, like fuel pressure. This is a 300 psi transducer. I mainly use this for running and cranking compression tests. And this is a 30 psi vacuum transducer. So anyway, you can see these fittings. This fittings actually came off my fuel pressure tester set. So it threaded right on the transducer. This one, and again, you guys are going to have to forgive me, I'm kind of looking through the camera as I'm doing this, so sometimes I reach for something that's not there. Anyway, this is your standard air chuck. Had to use an adapter to make it fit, but no big deal. So if these do become available for sale, you will not have these couplers. You'll have to either supply your own, which you can use from your fuel pressure tester set, which most any technician should have. I can provide them with these. In fact, I'll probably just provide all the transducers with these, and you'll just have to remove them or keep them depending on what you're doing. So again, I can't supply these ones, at least not at this time. Anyway, so these are the transducers, and we'll go over how they work. They require a 5-volt reference signal, so I have to use these power supply boxes. Now, there's many ways you can make these power supply boxes. I made it so that you can use them off the car's battery, the vehicle's battery. You could use a 9-volt battery internally, as long as the voltage is regulated to 5 volts with it is. I'm not going to open the boxes at this time, just because of a time issue. But anyway, if you really want to see what's inside them, we can make them. Everything is soldered, shrink wrapped, neatly put together. There is obviously a voltage regulator in here, as well as an inline fuse at 2.5 amps. That is to protect the voltage regulator. Anyway, so basically the box that I built, these are both the same except for the length of these wires. I did that so that I could stack the boxes and plug them in together, and I'll show you that in a minute also. But anyway, the box itself uses some double shielded banana leads, and I use my power probe battery accessory to power it up. I like it. It's the cleanest. Do you have to have a power probe to use this? No. You could just use, I have these alligator clips from my Handtech set. You could plug them in here and then attach them to the battery, and that will supply the 12 volts to the regulator. There's numerous ways you could do it. You could use cigarette lighters, whatever you want. But I just chose to use the power probe, so I can use my extension or just this, no matter what I'm doing. Anyway, so the boxes have where the 12 volt comes in. This is our connector. I don't know if we could see that. For the transducer, this will plug right into the transducer. And with the kits, I am also going to supply a 10-foot extension. So I actually made these myself. They use all the same style connector, so it is rather uniform and neat and clean. And if you guys know me from other threads and stuff like that, you know how I am about that. So anyway, this is our output signal, this is our ground, and this is our voltage signal. The way the transducers work is at half a volt would be 0 psi, and then 5 volts should be the full scale range. So if we're using the 300 psi transducer, half a volt would be 0 psi, and 5 volts would be 300 psi. So anyway, that's the way that they work. All these transducers will detect vacuum. However, the vacuum transducer is needed if you wanted to do a cranking vacuum test, which we'll get into. It actually gives you a lot of valuable information. So again, these are the power supply boxes. I only have 2 because I have yet to use 3 transducers at the same time. I would like to develop another vacuum transducer, because in case if some of you are familiar with oscilloscope testing, this vacuum transducer is not sensitive enough to pick up vacuum pulses from like a fuel pressure regulator. And what I mean when I say that is if you had a vacuum style fuel pressure regulator, if you were to pull the vacuum hose off, you could not put this transducer on the fuel pressure regulator, and as the injectors are opening, it would sense that pull on the regulator. Now you could hook this up to any vacuum source on the car, and it will pick up the vacuum. That's fine, but it is not sensitive enough like a map sensor or something like that. So I'm actually working on developing another vacuum transducer specifically for that. Now, what you could do though, and again, I'm sorry if I'm rambling or going back and forth here, but the reason why you would want something sensitive like that is because you'd like to see when the injectors are opening, okay, or stuck closed. You would see a waveform and you would notice that there was a disrupt in the pattern, whether it would be low or high, depending on if the injector was stuck open or not opening, whatever. Now, what you could do is you could use the 100 psi transducer, and you can hook it up to the fuel rail itself, like off the Schrader valve or whatever access point you're going to use. And let's say, hypothetically speaking, you had 50 pounds of fuel pressure. When the injector opens for a specific cylinder, you'll see the pressure slightly drop. And then as an injector closes, it'll raise up. And then as the next injector opens, it'll slightly drop. So you'll see that waveform. So again, if there was like a gap in a waveform or something like that, if you had very low pressure, it would show that an injector was stuck open. Or if one wasn't opening, you would see a gap, and then a high pulse, meaning injector's not opening. So you could do it that way. Anyway, again, I'm sorry I'm rambling, but just trust me when I say this. The vacuum transducer, this one in particular, is fine for hooking up to a vacuum source on the engine. But as far as detecting slight pulls of vacuum from a mechanical source, it's not sensitive enough. So anyway, back on to the demonstration. So anyway, these are the boxes. This is the extension, and this is what I use for my power supply for the boxes. What we're going to do now is we're going to do a cranking compression test with the vacuum transducer, the 300 psi transducer, and also an ignition sync. We really don't need to do the ignition sync for cranking because it might not always be correct, but it'll at least give us a reference. So we're going to use that. So some of the tools that are needed for this right now is we're going to need to remove the spark plug and then install whether it be a hose or this metal line that I have for my compression tester kit. Whatever you use is fine. You can use from a leak down set. As long as there's no Schrader valve in it, it'll work fine. We're going to do a secondary ignition, so we need our ignition clamp. We're also going to need somewhere for that spark to go. And this is out of my fuel pressure tester set. We're going to use this to hook up to our vacuum source and to our transducer. Has a little Schrader valve in it. Anyway, the vehicle we're going to be using right now is unfortunately a 1997 Saturn. Nothing glamorous. Also, unfortunately, there is no mechanical issues with this car. So we can't demonstrate an actual failed problem. Anyway, this is also a coil setup with ignition wires. If we had a coilover plug, we could just back probe, take one of our leads and back probe the signal wire to a coil, or we could use, this actually came with my Handtech scope kit. Not all of them come with it, but this is just an extension, so you could actually plug the coil in here, and then this would go to our tester, and then we could clamp over this and we would get our secondary ignition source. We don't need that obviously for this one, but anyway, we're going to go on the flat screen here so it's easier to see. I also have the Handtech wirelessly hooked up to the laptop, so there's no USB or LAN cable going to it. It's a nice feature to have. It's nice to be wireless sometimes. That way there's no wires getting in your way, trying to walk or trip over them. But right now I'm going wireless. I really like it. Again, if I don't know what scope you're using, I don't know if they offer the option for it or not, but this one does. It's a paid option, but in my mind it's totally worth it. So anyway, I'm going to go ahead and pause this for a second here, and then we're gonna set this up. Okay, we are all hooked up. What I did here was we're going to first do a cranking compression test. So I went ahead and on this particular vehicle removed the fuse for the injectors. This vehicle does not have, I apologize, I don't know why I'm drawing a blank here. The flood, where you would put your foot on the accelerator to the floor and it would put it in a clear flood. Anyways, the vehicle does not have clear flood, so I just removed the fuse for the fuel injectors. You could also just unplug them if you wanted to. Some vehicles, they're just not easy to get to. But anyway, so moving on. So we have our boxes powered up. I use, like I said, the male-female banana, the shielded leads, so they don't have a whole bunch of connectors at the battery. I have nice, clean, that's it, 1 and 1, and everything could just be back connected right in here. So anyway, it's the cleanest way I found it to be, so I like it. Anyway, here's our boxes. They're all powered up. We have our vacuum transducer hooked into a main vacuum source. That's our PCV. And then we have cylinder number 2. No particular reason, just pick 2 is the easiest to, well, they're all relatively easy, but I don't know, I just picked 2. So here we are. I'm actually using a short extension that I made for this one, and then I'm using the long extension for the transducer. And we have our ignition clamp. Anyway, so basically channel 1 on our scope is going to be the vacuum, channel 2 is going to be our compression, and channel 3 is going to be our ignition sync. So anyway, got it going right here. Sorry about the glare from the light. I'm just going to put this in, give me 1 second. We'll try and do most of this in real time, but it is kind of hard with one hand, so I might have to be pausing through here. We're going to put this in the trigger sweep and signal, so I don't have to stop it myself. Anyway, here we go. Sorry. Alright, let's see what we get. Okay. So, let me show you what we have here. 1 second. I'm going to turn this light off right now. It's a little bright. Okay, so channel 1, which is our yellow trace, is the vacuum transducer. And I'll go over in a minute what we're seeing here. Channel 2 is the blue trace. That is our compression. And channel 3 is our ignition. Now, I know some of you are probably looking like, what's going on here and here. This just appears to be waste spark. Normally they don't look like this. Why this one's doing that, I don't know. But anyway, you can see that our timing is, you know, just before TDC, so that's about right. And like I said, this is a no known issue engine. The car was here actually because it has front end damage, so it's irrelevant. Anyway, moving on. So what we are seeing here is basically between these two blue peaks is 720 degrees of crank rotation. So this is our top dead center. Ignition fires, piston comes down. This is our exhaust, which is not very prominent because we're just doing a cranking test. This is our vacuum, and now we're building compression again. What we have here is our ignition, which we just went through, and here's our vacuum. Now, why the vacuum is so important is that if we had maybe a vehicle with a leaking intake valve or a valve that's not opening, or even an exhaust valve that has an issue, we would see it. And let me show you. Basically, what we have here is, like I said, we're doing cylinder, what are we doing? Cylinder number 2. So this is not necessarily cylinder number 2's vacuum hump, but what we have here is each cylinder. So we have, this is a 4-cylinder, so we have 1, 2, 3, 4. Next cycle, 1, 2, 3, 4. Again, you can just see that this wave is a uniform pattern. If there was something out of the ordinary or an interruption, you wouldn't see it, and then you would know, okay, we have an issue with, it's going to be a valve. I really couldn't think of another scenario to where it wouldn't be a valve issue, provided there was, you know, 1, 2, and then this one was down here or up here, and then this one's back here. It's going to be a valve issue. So now you know where to start looking, and in what cylinder. If you knew the firing order, I'm going to assume that this would be, this is our cylinder, because this is when the intake valve is opening. So if you knew the firing order, if the firing order was, you know, 2, 3, 4, 1, it would be 2, 3, 4, 1, and you would be able to go from there. So anyway, you know, this is our cranking compression test. Everything looks good on this particular one, but again, you know, without an oscilloscope or the pressure transducers, where would you get this information? What would you have to do? You know what I mean? You would have to do what? A compression test. How are you going to verify ignition timing? I guess you would have to get out your timing light, clean off the balancer, you know, make sure the notch is even there. If it is, you know, you got to clean it, maybe put a little white out on it or some kind of marking paint or whatever it is to see it. You know, I mean, we did this in a matter of minutes. We've gained all this information and all this knowledge. So I think what we're going to do next is let's go ahead and do a running compression test, and then we're going to break it down in another program called a compression waveform viewer, and we'll go more from there. I'm going to go ahead and pause it just because I want to set up the triggers a little bit differently on here. So I'll be right back. Okay, I went ahead and changed our time base. We're at 50 milliseconds. In our cranking one, we were at 200 milliseconds. And it's just going to give us a better picture this way. Anyway, I also put the injector back in for the, put the fuse back in for the fuel injectors. At this particular point, there's really no need to use the vacuum transducer, but we're going to keep it hooked up. I did go ahead and pull the harness for the fuel injector for cylinder number 2. You don't want to have unburnt fuel in there. You're just going to wash out the cylinder wall, possibly do damage to the catalyst. It's unlikely for the short amount of time that we'd be running it, but it is still a possibility, and you know, if you can easily access that injector, I recommend just removing it. Takes 2 seconds. Now, if you had a vehicle where it might be a little bit harder to unplug the injectors, you know, some of them underneath the intake manifolds, whatever, I suggest doing this test as quickly as possible and not letting it run for a long time. Anyway, so we are still hooked up. We just changed our time bases. Now let's just go ahead and fire this up. I'm going to turn this light off again because it's too much glare on the flat screen. Anyway, So just give me a second, bear with me. Fire it up here. So here we go, this is our running waveform. We can go ahead and, this looks good. We'll just pause that. Actually, it's a little bit of interference in there. Let's redo this. Let's get a good one. Sorry. Oh, that's fine. We'll just do it that way. All right, let me turn this off. Show you what we got here. Okay. Yeah, sorry. That what you're seeing here is actually just some kind of interference. That is not any type of spike in the exhaust or anything like that. And anyway, let's back up here for a second. Now, what we can tell from this waveform, and again, you have to just disregard this here. This is nothing, even here. Anyway, what we have here is, and we'll just use this waveform right here. This 720 degrees of rotation. Again, what we have here is our compression stroke. We have our ignition event. This is our exhaust pocket. Now we have our exhaust valve open, and we're pushing out the exhaust. Now, let's just pause right here. What if we had an issue where we suspected that the catalyst was clogged? There's just a back pressure issue, too much back pressure. What you would see, and you would see it on a cranking waveform also, but you would really see it in the running waveform. You could also do a running waveform at 2,500 RPMs. This one we're just currently at idle, just to demonstrate what we're seeing here. Anyway, even at idle, if you had a back pressure issue, this is basically 0 psi. Okay. If we had a spike up in here, okay, there would be a restriction in the exhaust. So you don't have to pull an oxygen sensor that might not be in an easily accessible location. Even if it is, sometimes they are corroded, and I mean, even if they're, like even on this Saturn, it's right there on the manifold, but sometimes they're not the easiest to come off. All we have to do is pull a spark plug, install the transducer, and we are getting a vast amount of information. So again, what you would look for is if there was a spike right in here, okay, as that piston is coming up and that exhaust valve is open, you would see that there is too much pressure in the system, that it's not being able to push all that exhaust out, and there's pressure in here. Now, if you were to see a spike on the end of the exhaust stroke, most likely that would be a timing issue, which on most cars we could also just sync the ignition and figure out the timing, which I'll show you that with this waveform view in a little bit. But most likely, if there was an issue with the valve closing too early, you would see a spike in here because it's not allowing all the exhaust out, and then it would bleed into the intake. Anyway, so now what we have here is our intake. Again, this is our 0 psi line. So this is our vacuum as the intake valve's opening, and then we have our compression stroke all over again. So what we're going to do here, which I like that we can do with the Handtech, is we're going to save this image. And it's kind of hard for you to see this, but we're going to save it in JPEG format, and we're just going to name it SAT for right now. Okay, so let's save this. Alright, it's saying that it's saved. So we're going to minimize this real quick. Now, this is a program that I picked up off of a website based in Australia. It's basically a small community of guys that share waveforms. You can make a donation, and you can download this program amongst a bunch of other programs, which we're not going to get into. or you can make a payable donation or information donation, and you will have access to download these. So anyway, let's pull up our Saturn waveform. There we go. Yeah. So here it is in the viewer. Now what we're going to do is we're going to go ahead and invert our colors, which on the Handtech you could actually change the background colors to anything you want, really, but you can't change the waveform colors. And I like the black, and the only reason why I don't use the white is because channel 1, the yellow doesn't show up very well on the white. Anyway, so all we did was inverted the colors. What we're going to do here is we're going to go ahead and zoom in on a specific area. Okay, now with this program what we can do is we can map out, again I'm sorry I'm not really looking through the device, we can map out our 720 degrees of crank rotation by going peak to peak on our compression humps, or towers, whatever you want to call them. So that's relatively peak to peak. Okay, now we can inlay this. Okay, and now this is our power strokes, or a 4-stroke combustion engine. This is our 720 degrees full rotation. These are 30-degree increments. So anyway, we have our power stroke, exhaust, intake, and compression. So now what we can do is we can also start to map things out. If we knew the cam specs, you could punch them in here and it would show you when the exhaust valve should be open, when the intake valve should be open. Here's our overlap. When the exhaust valve would close and when the intake valve would close. So it's pretty good information to have here. So if you know the cam specs, then you could verify that everything is correct and working the way that it should be. Another thing we can do with this is I'm going to go ahead and move these out of here. I can also remove these cursors. It remembers everything that you did. So we hit this one up here, sorry, and we can measure. Hold on. Sorry, I'm like trying to look through the device as I'm doing this. If you notice, it's calculating the degrees. So put this right on our ignition event, and we are at 23 degrees before TDC. I don't know how correct that is. 23 degrees seems to be a little bit much, but if we were to look it up, maybe it's right, maybe it's not. But that's what we have right now at idle. This would change as the RPMs change. The timing would then therefore advance. So anyway, this could be correct. Anyway, we're at 23 degrees before TDC. Another thing we can do, if we were to know our voltages and put a cursor up here, which I didn't do, unfortunately, but that's okay. Let's get these out of the way. We could do these cursors. So let's say that this is 65 psi. Here's our 0, and then 10 psi vacuum. If there was an interruption, and let's grab this cursor over here. Let's say there was a back pressure issue. You could, let's say it was up here. Now if you notice these scales, see that scale, that's like 7 psi? That would be a big hump. And a 7 psi back pressure, that's a lot. So, but, even at 2 psi, like 3 is not good. If you had a hump right here, you would see it. It's prominent. So this is where the transducers and the oscilloscope come in. I mean, there's just so much information to be gained in such a short amount of time. time that's billable, mind you. If somebody wanted to know the compression on every cylinder, is there a way you could do that without actually physically pulling out every spark plug and doing a compression test on each cylinder? And the answer is yes, you can. And if you're wondering how that's done, then I'll tell you real quick. We would grab our amp clamp and do a relative compression test, which is basically cranking the engine over without it starting in either clear flood or removing the ignition or fuel source or something like that. And we would get our relative, just look up relative compression test, because this video is already going on too long. But anyway, if they were all relatively close, you could do that. You'd pull one spark plug, take a reading, and you can pretty much, figure out what all cylinders are at. It's a great time saver. I highly recommend that anybody purchase Oscilloscope and transducers. These transducer kits you can do yourself. I mean, I made these myself. I don't know too many companies that actually offer the transducer sets. I know Pico does, and I know it's like over $1,000. And I know Snap-on has a few transducers, and I know they're very expensive as well. I would like to build them and sell them at a fraction. But it depends on how well this takes off. I mean, I don't really see a huge market for this, so I don't know. But I wish there was a huge market, and not because I want to sell these. I mean, I don't. That's not it. I just really want people to take diagnostics a little bit more seriously. And this is definitely a step in the direction is owning an oscilloscope, using the pressure transducers and other scope accessories. And this is what we're doing for today. And again, I'll make more videos. This was just something that was thrown together. I know people have been asking me for weeks to do this. Finally just took a quick break to do this. And there's no pre-thought done. This is totally unscripted, and just a bunch of rambling. So I apologize. I apologize that it took over 30 minutes. If you watched the whole thing, I really appreciate it. Again, post your questions up, and I'll make some more videos soon. Thank you.